Hello, so today we are going to do this problem, which is Leetcode daily challenge, bag of tokens. So basically with this problem, we have an initial power and we have an initial score. So those are the two constructs that we have here, score and the power. And we have a bag of tokens that we get as an array. And our goal is to maximize the total score that we can get by playing the tokens in a strategic way. Now, what are the moves that we can play with these tokens? Well, the first condition is you can only play with an unplayed token. So this means basically you can use a token only once. And for a token, you can do one of the two things, and each of them has a condition attached. So you can play face up if the current power that you have is bigger or equal to the token value, then you can play that token face up. And if you do that, then your power reduces by the value of the token and you gain one, the score increases by 1. The other option is to play face down, and you can do this only if your current score is bigger or equal to 1. And if you do this play, then your power increases by the value of the token, so sort of the reverse of the first operation, and your score decrements by 1. So you can think of it as sort of the reverse result of the previous one. And the goal is to return the maximum possible score you can get by playing any number of tokens. You can play all of them, you can play 1, you can play 2, you can play none of them, but the goal is the maximum score you can obtain. So if we take a look, for example, at this first example, we can't do face up, right? Because power is 50, which is less than the value of the token. So we can't do this here. And if we can't do this here, that means our score will stay as 0. So we can't do this one because this one requires a score to be at least 1. So our score stays as 0, so it returns 0. For this example, the power is 150. So we can play with this token at position 1. So we can play face up, and our power reduces by the value of the token. So now our power is 50 and the score is 1. And now since the score is 1, we could do this operation, right, and play, but then our score will reduce by 1. Our power will increase by 200, but our score will reduce by 1. We'll end up with score 0. So it's actually better to only play with this token, and we get the score of 1. Okay, so that's the core idea. Now, if you also take a look at the constraint, they are not too big. The length can be up to 1000. So let's see how we can tackle it. Okay, so let's see here. So these are the rows that we have for the operations, and this is the array. So if you think about this for a minute here, we subtract from the power the token and then increase the score if we can play face up operation, and we add and subtract from the score if we can do face down. So what this tells you is that for the operation where we subtract from the power, it's always better to take the smallest value possible, the smallest token possible, because we can only do face up if the power is bigger or equal to the value of the token. So we want to try to preserve as much as possible from power, okay, so that the next token we are more likely to have it bigger than the token value, okay? And why do we want to maximize the number doing this operation? Well, the entire goal of the problem is to return the maximum score. We want to get the maximum score. So we want to be able to increment the score as much as possible, because doing this operation reduces the score. So it's not in our benefit. We only do it if we need it so that we can increase the power. So basically we want to do this operation only if this will increase our power by so much that we can do at least 2 here, so that we cancel out this subtraction, right? So the summary of this is we need to do the face up, if we are able to do it, it's always beneficial to do it with the smallest tokens value if possible, right? So since we want to do it with the smallest value possible, that immediately tells you, okay, let's sort the tokens array. Okay. Now the other side of that is we increase the power by tokens, and the higher the power value is, the highest possibility that we can implement face up and be able to increment the score. So again, in the same way, we want the token that we add up, we want it to be as the highest value possible when the score is bigger or equal to 1. Okay, and so here, basically highest possible, and here we want to take smallest. So basically, if we sort, that means for this operation, we want to take from the back, from the end, and for this operation, we want to take from the front to be able to take the smallest value. Okay, so that tells you immediately if you want to take from the front for one operation, take from the back for the other, you should immediately think about using either a Q, or if you prefer, you can use 2 pointers with a left and right pointers. Right? And so what this tells us is basically we can use just a Q to do the operations. And that's the core idea of the problem. There are a couple of other details in the implementation that I will go over, but this is the core thing. So let's see how we can do it. Okay, so let's implement what we just said. So we need to get a queue of the sorted list of tokens. So we want a deck so that we can get from the front, double-ended queue, so that we can get from the front and from the back. And so we want to add to it the sorted tokens so that the smallest one is at the front and the biggest one is at the end. And then we need two things. We need the best score that will return at the end, so that we will keep track of the best score that we get. And we need the value of the current score. Let's call it current score like this. Okay. And we want to continue as long as we have tokens, of course. Now we can do face-up operation only if the power, the current power, so you could define current power and assign power. Let's do that just for this to be clear. So only if the current power is bigger or equal to the token value, which is the one we said we want to do it with the smallest one possible, so the one in the front. So this means we can do face-up operation. So to do the face-up operation, we decrement by the token value. So let's just pop it, because once we use it, we can't use it anymore. We pop it from the front because the smallest is at the front. We increment the score by 1. That's what the problem says. And since we incremented the score, potentially this is the best score we can get because we want the maximum score. And so let's see if this is the best we can get. And so we take the max of it with the best score so far. So this needs to be current score plus 1. Now, otherwise, one thing we can do to make this actually easier, in one iteration, let's do only one of the operations. Let's not do multiple, that will complicate the implementation. Only one of the operations. Okay? And so, now if we don't have enough power to take the smallest possible, let's try to increase our power. And the only way to increase our power is to play face down. Okay, but we can only play face down if our current score is bigger or equal to 1. That's what the problem says. Now, if the current score bigger or equal to 1, we can attempt to increase our power and see if that gives us a better score. And so to do that, we will increment our power by the value of the token, which is, remember, we want to add the maximum value possible so we can have a higher chance of this being true next time, right? And so we pop from the back, so that's what we do like this, and we decrement our current score by 1. Okay. Now, if neither of these are possible, we can't use face up operation. We can't do face down. We should just stop and break, because if we keep going, then that's just useless. We will never be able to get enough power to do a face up, and we'll never increase the score to be able to be bigger or equal to 1. So in this case, we should just stop and break, right? So that's pretty much it. And if we run this and submit, it should work, and it does work, okay? So that's the core idea here. You can try to do it with left and right to get the space complexity down to O of 1, but that should be pretty easy to do. Instead of doing, when you are doing pop left, you need to increment your left, and when you are doing pop, you need to decrement your right. okay? But this is the idea. In terms of time complexity, we are doing sorting here, so this is O van Lagan, and we are doing this operation which is at most O van and being the number of tokens. So overall, this is O van Lagan time and O van space. Yeah, so that's pretty much it for this problem. Thanks for watching and see you on the next one. Bye.